My quest for the ultimate space-saving DOS rig has mostly led us to laptops. In my last MS-DOS Laptop Showdown series, we found some absolute gems. But as great as those machines are, we eventually hit a ceiling. Not a performance ceiling, but a choice ceiling. In a laptop, you're married to the hardware the factory gave you. In this new series, I want to break that ceiling. I want the compactness of a laptop, but the modular soul of a desktop. If you're new here, greetings, and to my regulars, welcome back. This is the Allen Bradley 6181. Normally, these are prohibitively expensive industrial tools, but I found this unit listed for a bargain because the screen was dead. Now, usually I'd stick to the laptops we rank in my leaderboard showdown video, but the specs here were too good to pass up. I took a bet. If the motherboard works, we have a monster. If not, well, it's a very expensive boat anchor. First look, this 10.4-inch unit is built like a tank. It's part of the RAC 6181 family, and while it exists in various CPU configurations like Pentium 3 and Celeron, this one is special because it's equipped with the Pentium MMX, which is a great CPU because of its performance tuning capabilities. But more on this later. Moment of truth? That is loud. But the screen remains pitch black. I can see displayed content at an angle though. Let me connect it to an external monitor. And success! To me, this must be a backlight failure. It's probably a delicate fix, but totally doable. Let's try it again. We have a picture. It's vibrant, sharp, and perfectly industrial. Accessing the BIOS settings requires pressing the F2 key upon power up. It is a family of Phoenix BIOS with the typical settings. Now that the gamble has paid off, let's add a hard drive to see what this beast is capable of. Getting inside is like opening a safe. It's a backplane design with a single board computer that plugs into a vertical bus. Here we can see the Pentium MMX CPU, which is the king of DOS flexibility. The build and the component quality are exceptional. Notably, no electrolytic capacitors, which eliminates the risk of them leaking or swelling over time. The Pentium MMX is my favorite CPU for DOS gaming. While you can't adjust the frequency multiplier, it does allow for tweaks to the branch prediction, code cache, data cache, and the V instructions pipeline. Let's go back to why I picked this system. Look at it next to the Toshiba CDT660, a standout from my previous laptop review. Make sure to check out that video by clicking on the card. Both share a space-saving spirit, but solve it differently. The Toshiba is sleek but locked into the factory audio. The Allen Bradley is bulkier but offers PCI and ISA slots, letting us choose our own sound cards. For this review, I have decided to use this compact business audio ISA sound card. It features an ESS audiodrive 1869 chip. I really like this card because it also has an ES692 Wavetable chip with integrated 2 MB of ROM of surprisingly high quality sound samples. Another huge benefit is the availability of a game and MIDI port through the sound card, which is very hard to find on laptops. Let's talk performance. Using utilities like SETMUL and MOSLO, we can dial down this 233 MHz MMX. Here's a quick tutorial. SETMUL supports the following parameters to control the various performance flags of the Pentium MMX CPU. And this is done by simply typing SETMUL followed by the desired flag parameters, which are CCD for code cache disabled, DCD for data cache disabled, BPD for branch prediction disabled, VPD for vPipeline disabled, L1D for level 1 cache disabled, and L2D for level 2 cache disabled. To enable any flag, just type SETMUL, the desired flag, but instead of ending with a D, type an E. You can combine multiple options as well. For example, to disable code cache but enable data cache and disable branch prediction, type SETMUL, CCD, DCE, and BPD. To reset everything to the default state again, type SETMUL, FPE. 3D bench results indicate hardware flags tuning could scale performance down to 486-33 MHz levels only. This is due to the higher base frequency of the CPU and also because the cache operates in write-back mode only. There's no way to set it to write-through mode. For those early speed-sensitive games like Test Drive 3, I have to resort using the MOSLO utility as well. Now they run better and are playable. However, MOSLO works by skipping CPU cycles, which prevents it from able to provide buttery smooth performance. For 3D games, the Chips and Technologies graphics chip is solid for compatibility, but don't expect Quake to fly. I obtained 17 frames per second at 640 by 480. And since the display's native resolution is 800 by 600, games below that will run with blank borders. Fortunately, there's a neat utility called VEXP, written specifically for the Chips and Technologies graphics chip to scale video full screen. This is done by typing VEXP with the M2 parameter. And voila! All games will now run full screen. And so far, every game ran great. Paired with the compact sound card, we can enjoy amazing wavetable audio. With the MIDI game port, we have added flexibility to connect game controllers or sound modules such as the Roland Sound Canva or an MT-32. optical drive, floppy, USB, and network ports, moving files is a breeze. My only wish? A video loopback connector. I'd love to route a 3DFX Voodoo card back into its built-in screen. Maybe that's a project for a future video. But besides this, that's hell a lot of machine, with almost everything you need for native DOS gaming. If you enjoy this industrial gamble, you will love my mini bookshelf 386 and 486 builds. Make sure to check those out next. It follows the same small but mighty philosophy. Thanks for watching. You can show your support by hitting the like button, subscribe, and I'll see you in the next build.